force is going to point A, it doesn't create a moment. Brandon, what about point B? What's going on at point B?
For the force at point B, there's no moment created.
No moment, so only this guy creates a moment, right? 100 times 3 and it's negative. And then at point C, or W, at point C, this 100 creates a what? Positive or negative?
Positive.
Positive. How about that one?
Negative.
Negative. So what do you find out in the end? What conclusion can we draw? We have one being, one body. It has two forces. They're both the same magnitude, opposite directions. There's one couple in this problem. And what did we find out? The moment at point O, moment about point A, moment about B, and moment about C. Iliad, what did we find out?
They're all the same.
They're all the same. So that means that whenever you have a couple, I'm trying to write it big so you guys over there can see it. Whenever you have a couple, the moment is the same at any point on the body or on the structure or body, whatever you want to call it. Take a look at these two forces here. Does it make sense when you see this one up on the left and this one down on the right? Does it make sense that the moment should be negative? Think of this as a spin. If this is going up, I'm kind of making a circle. This is going down, this is coming up. So in the end, anything, when I have a force up and a force down, that's creating a negative moment. How about this? What does that create? Negative or positive?
Negative.
Negative. Follow my fingers. If it's spinning around this way, it's going to be negative. What about this? Positive. My thumb's going to be sticking out. What about this? Positive. How would I calculate this then? If we found that a couple of 100 pounds creates the same moment at any point on that beam, how can I figure it out without doing all these calcs? How did we get 300 from the 100?
The distance between the two?
The distance between the two. So the moment due to a couple is going to be the force times the distance between them. Everybody got that? So a moment at any point when there's one couple or two couples is the force of the couple times the distance between. And it makes sense because that is the perpendicular distance between the two forces.
It's the force of, when you say force of the couple, it sounds like you're adding 100.
This is a 100-pound couple, right? It's a couple because a couple is two people or two this. So this, in this case, a couple, it's singular. A couple is two forces. So if I take the force and multiply it by the distance between, the perpendicular distance, that's my moment. Santiago?
That was my.
Okay. So let's do some examples. Don't look at the stuff up on top. That has to do with the previous page. I moved the page down just so that I could write it correctly on the whiteboard. So, Chris C., we're up to you. So the first thing you do when you have a statics problem from now on is you look to see if there are any couples. Because If I ask you to find, everybody look here, if I ask you to find the moment about point oh, I no longer want you to do all this work, because I first want you to sweep through the problem, take a look, and if it's a couple, I'm just gonna multiply 100 by 3 and put it in negative and I'm done. I don't have to do all this work. So the first thing you do now in statics problems is look to see if you have any couples. So Chris, do you see a couple? Okay, tell me which one you see.
60.
Okay, so 60 Newton and 60 Newton. They're both the same magnitude in opposite direction. Santiago, do you see another one?
Sorry, what was the first one?
60, let's write it up here. So Chris found the 60 and the 60. Did you get
75 and 75.
some water? Yeah, 75 and 75. Isadora, you see one? 75, 75, 80, 80. Have it anymore? 50, 50. So David, how many couples do you see?
4.
4 couples. Are there any other forces in this problem besides the couples?
No.
No. So what kind of motion, Chris L., what kind of motion can be the only motion produced in this problem?
It's just gonna be rotational.
What, okay, why?
Because they're all couples. so-
They all couples only produce rotational motion, but let's think of it another way. If we have an 80 up and an 80 down, it's 0. If we have a 60 to the right and 60 to the left, it's 0. 75 to the right, 75 to the left, 0. 50 up, 50 down, that's 0. If we added up all these forces, the forces would be 0. If it's 0 force, if we have a 0 force, then don't we have no translational motion? Right? So we only have rotational. So Andrew, using the 60, so let's look at the 60. We have a 60 to the left and a 60 to the right. What's the distance between?
325 millimeters.
325 millimeters. So what's the moment created due to that 60?
60 times 325.
60 times 325, positive or negative?
Negative.
Oh, wait. I drew it wrong. Right? I drew it wrong. The top 60 is to the right, the bottom 60 is to the left. Sorry about that. Positive or negative?
Negative.
Negative. Okay, how about the next one? I gotta drink some. Mark, pick another one.
75 Newton?
75. So where's the 75? The 75 is going,
F and B.
so 75 on top is going to the right, to the left, and on the bottom it's 75. What's the perpendicular distance between them?
125 millimeters.
125. What's the moment going to be then?
It's going to be positive.
So 75 times
125.
125. I'm looking at it this way, use my right hand rule, and I get a positive. Santiago?
I don't see how you're choosing the sign for what you're multiplying by.
So we're using right hand rule, right?
Okay.
So it's the absolute value of the force times the absolute value of the perpendicular distance, and then I use my hand to determine positive or negative. And if the force is going this way on top, and it's going this way, it's spinning like this. And this is a negative. Right? Got it, Santiago? Wes, right?
I just realized I had positive and negative. Counterclockwise has got positive.
Yeah, so always use your right hand. If we
It's
have,
coming at you, is that how you determine that?
so here's the positive x-axis, right? And we could just draw the positive y-axis. If we have the x-axis positive going to the right and the positive y going up, which way is z? Which way is z positive? Coming out of the board, right? Everybody agrees?
Yeah.
If you have a positive x, positive y, positive z. And we know things spin positively if my thumb points in the positive direction. So if positive z is coming out, if I have my thumb like this, I get a positive. But if my thumb is sticking inside the board, it's a negative. Okay, so we did the 75 and we did the 60. Now do the 50 and do the 80.